In this test drive, we're going to explore enterprise integration patterns as implemented in the Fuse ServiceWorks platform. The test drive will focus on the following patterns: message translator, request reply, correlation identifier, return address, document message, canonical data model, message broker, and message gateway. The primary focus will be on the message translator pattern. There will be future test drives that will explore other patterns. We're going to use a retail scenario to demonstrate these patterns. In this scenario, we have an order management system that exposes operations via SOAP. We have an e-commerce system that would like to interface with REST and JSON, a point-of-sale system that would like to use JMS and XML, and an EDI system that would like to drop files in EDI format. We're going to use the Fuse ServiceWorks as our broker to mediate the exchange of messages between these systems. Now let's take a look at the test drive. The virtual machine for the test drive comes pre-configured with a development environment and a Fuse ServiceWorks server installation. Let's launch our development environment. The development environment has 3 projects. OMS Gateway is a completed implementation of our gateway. OMS Gateway Work is our working copy that we're going to use to start with. And OMS Mock is our mocked out implementation of an order management system. This is our SOAP service that will be our OMS system. We also have a server configured in our development environment. Let's first start our server. Okay, now that the server started, let's take a look at the OMS system that we've mocked out. We're going to launch SOAP UI. SOAP UI is going to allow us to invoke our OMS system via its SOAP interface. Our OMS system exposes 2 operations: a create order operation and an order inquiry operation. The SOAP format of the message for create order is as follows. We can submit this order, and the response is just the same order echoed back to us. If we execute the order inquiry to dump all orders, we'll see now that we have 1 order in our order management system. Okay, so now let's get started with the test drive implementation. Again, we're going to start working in OMS Work. It already has a few resources that we'll need, and we'll finish out the implementation. So in the source meta-inf is the switchyard.xml file, which is our primary configuration file for Fuse ServiceWorks projects. We have a blank palette here that we're going to start creating our service implementation details. We're going to use a camel Java DSL route in order to perform our routing logic. So that's where we're going to begin. So we're going to drag this over to our palette, and all services in Fuse ServiceWorks need an interface. We can either create a new interface or browse and use an existing interface. We're going to create a new interface. We're going to put it in our service package, and we're going to call it OMS Gateway Interface, and finish. And then now we're going to go ahead and finish out our service implementation. Again, we're going to put that in our service package. We want to call our service just OMS Gateway, and we will make our implementation class be OMS Gateway Route. So now we click Finish. We now have our route. The route is going to be our centerpiece orchestrating our services. So now that we have an interface, we need to add operations to the interface. So let's open up our OMS Gateway interface and add an operation for each one of our OMS operations. So we have two operations that we would like to add. These are create order and order detail inquiry. In the domain package of the application, there already exists the JAXB objects that will be our parameters to our operations. We have an order list, an order line, and an order query. So these are the objects that we're going to pass forth back and forth in our REST and our JMS message exchange. So now we have our service interface and our two operations, one to create an order and one to do our order detail inquiry. Let's save that and return to our switchyard XML. So the next thing we want to do is add we want to turn that Java interface into a WSDL interface. So we are going to perform that task, and we're going to unwrap the messages. This WSDL interface will be used later in our transformations. So now we need to bind the service so we can have a service reference to our OMS system. To do that, we need to create a reference. And we're going to use the WSDL that we just created as our interface to our OMS system. Next, we need to promote that service to an external boundary. We're going to use a different interface this time. We're going to use the actual WSDL of the OMS system. We're not going to create transformers at this time. We'll do that later. Click Finish, and now click Save. Now that we save this, you'll see that a red X appears, and we get a warning message that we have 4 required transformers missing. That is because our service has an interface that have our messages in our gateway format, or JAXB objects that our REST service is going to expose. And the OMS system has their SOAP messages that the OMS system expects. We need to actually create transformers that will transfer to and from these object types. Let's do that next. So let's click on the property sheet and go into the transform section, and we can start adding our transformers. Under our resources here, we already have pre-configured XSL style sheets that will transform our messages. We're just going to bind those. So let's click Add, and we're going to do these one at a time so we can pick the XSL for each file. So in this one, we're going from an OMS order to our gateway order format. We're going to use XSL. We're not going to create a new XSL. We're going to browse and find an existing one. So we're going to we're going from OMS order to gateway order. And finish. So next, we're going to go from the OMS order list to gateway. Now we have an OMS order going to a gateway order. Sorry, that was a gateway order. A gateway order to an OMS. And the last one will be our order query. So now that we've created our 4 mappings for our transforms, we can save again. And our error message goes away. We now have met all our transformation needs. The last thing we need to do to interact with our OMS system is actually create a binding to the SOAP endpoint. So in our service now, we add a binding for SOAP, and we need to provide the actual endpoint address, and it will be for an actual OMS system. This would be an external address, but we're running this on the same server, so this is our endpoint address. I click finish, and now save. So now we've done our configuration of our service reference to our OMS system. We now need to create a REST interface so our service can be exposed externally. To do that, we promote our interface to our external boundary. And now we need to bind that to REST. We already have a REST interface defined for our 2 operations. So all we have to do now is bind that to our interface and give it a context path of and add the interface. And we need to go next, and we have to add a composer class to this. The composer classes are used to map incoming messages to the actual payload of our service. And in this case, for our REST service, we had to create a custom composer to handle query parameters. You can take a look at the composer and see the implementation yourself. So now we have our REST binding, so external systems can now invoke our REST interface, and we have a way of calling our OMS system. Now all that's left to do is actually implement our routing logic in our CAML DSL. So let's go into here, and we have to do a couple things. Our routing logic is fairly simple. We just need to add to our OMS endpoint that service reference that we've created. So the incoming message is already going to be coming here. It's going to log, and it's just going to print out the incoming message, and then it's going to route to the OMS system and return the response. The one issue we have left here is The format of the response object from this call is it's using XSLT, so it's an XML DOM object. We need to convert that back into a Java object so that our REST endpoint can return it properly. To do that, we're just going to add a couple bits of information here. Another transformer. We're going to add a JAXB marshaller. So after we call the OMS system, the last thing we're going to do is unmarshal the XML object back into a Java class to return to our service. That's it. That's all we have to do to now create a REST binding and link up our transforms and call our SOAP service. Now let's build and test our REST endpoint. Under run configuration, we've defined a deploy task that will run the Maven clean install and JBoss AS deploy command to deploy our service on our Fuse Service Work server installation. Our build is successful, so now our service endpoint is deployed. Let's launch Firefox, and we have REST client installed in our Firefox, and we have some predefined requests. So let's create an order using JSON. So this is our JSON format of an order, and we can submit that, and we'll see we get a 200 status code back, and we can look and we get our JSON payload back of our order. We can now come over and let's actually do a get orders as JSON. So we're going to dump all the orders in JSON format. We see we have the order that we just created with our REST using JSON and the order that we created previously with our SOAP. So we have two orders now in our OMS system. We can also use XML payloads in our REST interface. Those operations are defined also, so we can create an order using XML payload over REST, and we can dump orders, get orders as XML. So now we have 3 orders in our system. We're looking at the XML of the 3 orders that are in there. So that's it. That's all we had to do to create a REST binding transform between our REST JAXB objects to our SOAP interface and back. So now let's continue on. The next thing we want to do is add a JMS binding to this endpoint. To do that, all we have to do is come and add another binding. And this time we're going to pick JMS. And now we get configured our JMS binding wizard. So what we want to do here is define our request queue and our response queue. We've already predefined these queues in our server installation. So this is demonstrating our request reply pattern over JMS, where we have a incoming queue, and the response object is going to get written to the reply to queue. We're going to support just one operation over JMS, and that is our create order operation. So we need to map that. We now click next, and again, just like the REST interface, we have to do a little bit of special message composing. So we've created a OMS JMS composer class. And again, you can look at the implementation of this. What we're having to do here is when the message gets sent to the reply queue, this composer class will take the Java object that's returned from our service and actually turn it into XML, so we're using text-based messages on JMS instead of object-based messages. Again, you can look at that implementation. We now click Finish and click Save, and that's all we had to do now to turn our to create another binding to our service that's now JMS-based. Now let's test our newly created JMS binding. In the source test Java location, there's a JMS test client. This test client connects to our JMS queue, sends a message with a correlation ID, and then reads the response message off the reply queue. All right, first let's build and deploy our project. Our updated project has now been deployed. Now we can run our test client. The test client actually reads an input file, test order JMS1, located in the source test resources folder. So we're going to be adding order JMS-555. So we run our Java application, and if we look at the output from the run, we see the input order and we see the echoed out response order. We can now go back to our REST client and dump the orders again. And see that our JMS 555 order now has been added to our OMS system. Now we've completed the REST binding, the JMS binding. The last step will be to create our logic to process our EDI files. To do that, we're going to add an additional camel route. So let's create an interface for our EDI. And name our service. And now update our interface. So our interface, we're going to add one method, and it's going to be create order. Our response object is going to be a void because we're going to do a one-way exchange for a file. We're not going to do a response. And the input is just a string that represents the contents of the file. So now that we have our interface, we're going to generate a WSDL just like we did with our prior route. And again, we're going to unwrap the messages and save. So we need to add a component reference to our OMS service through our EDI gateway. And we're going to use that WSDL that we just created. And we're going to bind it to OMS. So once we save our project, we're going to see that we're missing a transformer. That's because our EDI format doesn't match our OMS format, so now we need to create a transformer. The EDI files are in a different format, so we can show an example. So the EDI looks like this. Fuse ServiceWorks supports many different ways to do transformations. We're going to use a SMOOCS transformer because SMOOCS has a built-in EDI cartridge that will allow us to do that transformation. We already have a SMOOCS EDI order configuration file that uses the EDI reader to process the EDI file and then applies an XSL style sheet to get it into our structure of the SOAP message. So we need to add that transform just like we added the others. So this time we're doing a SMOOCS transformation. And we're going to browse and find our SMOOCS EDI to order XML. Click Finish, Save, and our error goes away. We now have a warning, and that's just telling us that we're not processing the return object. So now we need to promote our interface and create a binding for our EDI file. We're going to pick File, and our file reader is going to read from this folder. So any file dropped in this folder is going to be processed. And we need to map our operation. We want to do create order. And click Finish. So now we have a binding on our interface that will read files that are dropped in the input folder. It'll call the route, and then the route has the capability of invoking the create order OMS operation. We just need to add a little bit of logic to our EDI route. So we need to route that to our OMS service. And in the beginning of our route, we need to add this line to convert our incoming message to a string. By default, the file reader returns a message of a file object, a file handle, to the route. By converting it to a string, it will read the contents of the file and then that will become the message that's passed to the OMS system and then convert it. So that's it. So now let's save that and build and deploy one more time. So our EDI route's now been deployed. So under source test resources, we have our input folder. We can copy the test order 1 EDI file to our input folder. And we see that our EDI order was processed and the order was created. If we want to verify that, again, we can return to our REST endpoint and dump all the orders, and we see now we have the EDI order in our system. That's it for our test drive demonstration. You can now log on and try it for yourself.